Here's my data. A one-way ANOVA test was already completed. What I'm going to need out of this for the critical value are the degrees of freedom, 2 and 12. Excuse me. And then this is how you perform the Scheifele test. It looks really difficult, but we will figure this out. Okay, so the first thing is the critical value, degrees of freedom. I don't know if you saw this, but it was 2 and 12. Okay, the other thing here is, no, that should be good. All right, everything here should be good. Go to solve. 3.89. Okay, now I'm not entirely sure why. I'll maybe have to do some reading to figure this out, but this isn't our critical value. We actually have to take this number times 2. So 7.77 is our critical value. Again, we haven't had to do it at any other time. Not entirely sure why it happens here, but that's what we have to do. Okay, maybe because we're comparing two pieces of data. I don't know. Okay, so how do we find this number? We're going to go into here is where this is the formula for it. I'm gonna make this smaller. I'll just move it over to the side. And then the other thing we need is the data, which is here. Okay, so here's my calculator. I'll make it a little smaller here so you can see all of it. Okay, so I want this formula, and I got most of the numbers. This should work. Oh, no, there they go. Okay. Well, anyways, I'm going to go math, fraction, to give myself fraction, and then I want the mean of A minus the mean of B. Well, the mean of A, in my problem, A is very good, B is good. So I'm going to look here. Here's my very good mean. Here's my good mean. So I want those two numbers on top in parentheses. So I want 0.453 minus 0.606. End parentheses squared. That's the top. That's the top. Okay, now I want to do the bottom. Okay, the bottom again, I'm going to put a fraction just to make it nice and neat. This first number is SSW. Well, if I look on here, SSW is the sum of squares within. So 0.09035. Over this sum of ni minus 1. I'm not entirely sure why they use this notation and why they just don't say degrees of freedom for the denominator, because these are the same. So I'm going to put 12 there. Okay, and then here is going to be 1 over my sample size for my A, which in my case was very good, so 1/6. Plus 1 over my sample size for B, which in my case was good, so 5. And hit enter. So my value is 8.48. And then it'll ask us to do this 2 more times with, so we just did a very good with good, and then it'll ask us to do very good with fair or good with fair, but so we're gonna do this 2 more times, and you're trying to compare all of these F values to this F value. Any F value that's bigger than your critical value means that there's too big of a difference between the two means, and maybe we can see that. These are all in their 40s. We got 1.51, 1.37, so maybe those set each other off. Here's our average of 0.453. If you notice, all of these are in the 60s, except this one. I guess this one's not quite there either, but we can see there is a pretty good difference in the means, and that's what this is supposed to calculate. It's supposed to try to find if there's too big of a difference in the data sets between two of them. Okay, so I'm not going to finish this problem. I think you can finish it after this point. We'll see. If not, please ask questions, but this is my value for the first one, and when I get to the end of the problem, I'm definitely going to have to reject the null for this one because this is in the rejection region. So there is too big of a difference between those two. Okay, I'll leave it at that.